Hey, my name is Gustaf Nilsson Kotte, and I work as a senior software engineer at IKEA Retail, Ingka Group. I want to start this session by very briefly describing the IKEA.com web platform. Then I will describe some problems we experience with this platform and what happens if we don't fix these problems. After that, I'll talk about edge computing and developer experience. Finally, I will show you 2 examples of edge computing from our production environment using Fastly Compute Edge. But first, IKEA has 474 stores in 64 markets. IKEA Retail, Ingka Group, operates a majority of these markets. IKEA's vision is to create a better everyday life for the many people. And Ingka Digital is responsible for serving over 4 billion online customers worldwide. We are 2,800 digital professionals in 8 growing digital hubs, some of them in Sweden, in Amsterdam, Madrid, Philadelphia, Shanghai, and Bangalore. And we are a multi-cloud and multi-CDN organization. When developing and operating a website of this scale, we need to make sure that it's secure, available, performant, and indexed and ranked high in search engines. For example, the core Web Vitals performance metrics need to be all green. Good web performance is necessary for a good user experience. IKEA.com is developed by 50 teams from Ingka Digital. The web platform enables collaboration and reusability between the teams by using fragments, small portions of HTML that we compose using either edge side includes on the server side or Ajax on the client side. IKEA.com also uses a static files architecture. We have over 40 million files in use. These files enable both static sites and JavaScript single-page applications and components. However, this architecture also introduces some challenges. Let's look at some problems to solve. We need to be able to increase the relevancy for our customers. Today, many parts of IKEA.com is exactly the same for everyone, regardless of where the customer is in their journey. If they maybe are working on a specific project, or if they are a private or business customer. And one size does not fit all customers. We also want to scale A/B testing practices and grow the experimentation culture within Ingka Digital. We want to be able to attribute changes we make to customer value improvements. And this is really hard to do without A/B testing. A/B testing gives us better data faster. Finally, we want to do this in a web performant way. We especially don't want to increase cumulative layout shift, CLS. But why are we concerned about CLS for the above needs? Let me show you an A/B test causing CLS. So this is an A/B test developed with client-side JavaScript. We will refresh the browser, and with 0 CLS, you should see no elements bouncing around. The upper limit for good CLS is 0.1. Bad CLS is 0.25 and above. Please look carefully. As you see, there's a lot of elements bouncing around, and the CLS value for the refresh is 0.76. Not great. Not all A/B tests cause CLS, but it's sometimes very hard to avoid. Similar effects can be seen for personalization implemented with client-side JavaScript. To summarize, we want to scale A/B testing practices and increase customer relevancy with personalization, but we don't want to increase any performance problems at the same time. So instead, we need to move the logic and rendering to the server side so that customers get different HTML responses from the server depending on, for example, their user journey, or if they bucketed into one or several A/B tests. This way, the elements will not bounce around and cause CLS, because the HTML is already fully constructed on the server side. So, we go back to our high-level capabilities for the web platform of IKEA.com and add dynamic responses as a way to deliver HTML. But how can we then achieve dynamic responses at IKEA.com scale, both in terms of traffic and the number of teams? Regardless of how, The solution needs to be globally distributed because we have customers all around the globe. HTTP requests crossing a sea just increases latency too much. But even if we have a globally distributed compute, it itself, of course, also needs to be performant. And it needs to have good developer experience and scale to the many teams. We have started to look at edge computing as a way to get dynamic responses for IKEA.com. So, what is edge computing? In a website context, edge computing means a large number of nodes with a serverless operating model. The developers treat these nodes as a single network. For example, deployments and configuration management are global. If then teams need to deploy something more local, feature flags and conditionals can be used. Edge computing scales up and down seamlessly, often with small cold start times. And edge computing means that teams don't have to worry themselves about the distribution of their compute, neither about the consolidation of metrics and signals. If modern cloud computing went from pets to cattle, edge computing is more like going from individual cattle to a single cattle herd, globally distributed. So edge computing has a great operating model, but to get sustained success, developer experience must be great too. So let's talk about developer experience a bit. Developer experience is basically UX for developers. And bad UX, user experience, leads to longer time to complete tasks, easier to make mistakes, frustrated or unhappy customers or users, and they start looking for alternatives, eventually leaving. And bad UX can even cause brand damage. And the same reasoning goes for developer experience as well. So what then makes for a good developer experience? For web development in this scale, I think there are at least 4 categories: learning, feedback, automation, and operations. First impressions matter, and there needs to be a good development model and abstractions, and also great documentation. Feedback is essential to development. Therefore, local testing, support for automated tests, and easy to get observability is key. We really like open telemetry, by the way. Further, the command line interface needs to be good, and it also needs to be easy to do continuous deployment. Finally, to not need to think about and work on scalability, availability, and reliability allows us to spend this time on creating more customer value instead. What we have seen so far is that Fastly Kubernetes Edge has a good developer experience. And that thing that makes Kubernetes Edge unique is where we need to be extra clear internally. Because Kubernetes Edge is a WebAssembly-based edge computing platform, and not all libraries or frameworks will work out of the box. This is especially important for JavaScript developers to know, since they're often used to having Node.js as their server-side runtime. And SpiderMonkey WASM and Node.js are not the same thing. So again, it's important to be clear and set the right expectations in the beginning. We are quite early on this journey with edge computing, but I'd like you to show 2 examples already in production today using Fastly Kubernetes Edge. Unfortunately, neither example is related to personalization nor A/B testing, but hopefully I can show something of this on the next altitude instead. Our financial services team develops a product that let our customers do a partial payment. Due to the nature of static files and also underlying system requirements, they needed to create around 1 million files per market to display this text with variable monthly costs. Migrating to Fastly Kubernetes Edge using the Kubernetes Edge JavaScript support and React, or actually Preact, allow them to completely remove their static files and instead render the result dynamically at the edge with an average compute time of 10 milliseconds. Another team is the JMagical team, who has a product called Creative in Swedish. It's an AI-powered virtual and mixed reality room design tool. From the start, the web frontend for this product was written as a single-page application. But when the team needed to support social media sharing capabilities to the product, they encountered challenges since the metadata tags needed to be dynamically generated. And this team spent a couple of days to proxy the web frontend with a computer edge service written in Rust, which allowed them to dynamically inject the metadata tags needed to get a social media preview of customer designs. So just a couple of days of work to get a global distributed service up and running in Rust. So finally, some key takeaways. To increase customer relevancy and A/B testing without decreasing web performance, especially CLS, IKEA.com needs to use dynamic rendering. We're excited about edge computing as one tool in a toolbox for becoming more dynamic. And still, we're just getting started. And great developer experience is key for sustained success. Thank you.